I'm going to go through how to set up your titration curves so that you can do the things that you need to for your lab report. What I have here is a typical titration curve. In this case, it's a weak acid, strong base titration curve. You're going to also collect a strong acid, strong base titration curve, and you're going to treat that a little bit differently. There's one thing you won't do with that one, and I'll point it out as we go along. But with this one, I have two things I want to do. Now, the way the lab report is written, I can do those in Excel, and that'll work just fine. But we've also discovered a way to do this in Data Studio that works just as well and is less hassle. So here's what I'm going to do. I need to find the equivalence point for this titration curve, and I'll need to do this also for my strong acid, strong base titration curve. The way I'm going to do that is I'm going to set up a second derivative plot. In Capstone, I'm going to go to the Calculations tab, and what will happen is this will come out. I'm going to go down to the Special button down here and select Derivative, which is right here. If I click that twice, that's what I need to do. That'll give me a second derivative. And then I'm going to type small p, large H, for the measurement that I'm going to take the second derivative of, and then I'm going to click Accept, and that's all I have to do for this. Now I can close this. Okay, so what's that going to do for me? That's going to tell me exactly where this curve crosses its inflection point. In other words, the direction of curvature changes. That's defined as my equivalence point. So how am I going to find that? I'm going to create a new graph. So I go up here and I click on this, Add New Page. I'm going to drag the graph over, drop it. On the y-axis, I'm going to select this Calc1 value that I just made. There's my second derivative plot. Now on the x-axis, I am going to use volume. Okay, and so it looks like my second derivative reaches 0 right around 25 milliliters, which is what I would expect. But I want to be as precise as I possibly can. So I'm going to expand this region of the graph. And the way I'm going to do that is I click on this button here. I get a little selection box. I'm going to slide that over and then resize it so that it covers just the area right around 25 milliliters, right around where my equivalence point is. Where we get this sharp cross of y equals 0, that is our equivalence point. Okay, now I can go over here and click on this scale to fit and expand that. And there I have it. Now I'm going to look at this later on in another application so we can see more clearly what's going on. Now there's one other thing I want to do with the weak acid strong base titration curve that I don't have to do with the strong acid strong base titration curve. And that is I need to expand the region of half equivalence. Now I know that's going to be right around 12.5 milliliters. And so what I'm going to do is I'm going to create a third plot by setting up my graph. I'm going to make essentially a duplicate titration curve plot by putting pH on the y-axis and volume in milliliters on the x-axis. But now I'm going to expand this small region of the titration curve right around pH 12, or right around 12.5 milliliters of added base. The way I'm going to do that, again, is I'm going to click on this little box. I'm going to bring it down to about so, and then I'm going to resize it so that it covers just a very small region of my titration curves, say between about 11.5 and 13.5 milliliters. Now I can click Expand again. And there I have what I need. Okay, so I've got 3 graphs. I can go ahead and print those 3 graphs out. I also took away the table and the digits from this, which makes it look nicer. So I go to my page setup under File or Print Preview. All right, I've got this set up already to print in landscape. In most cases, you're going to see something like this. You want to change to landscape because it gives you a bigger graph. And then you can go ahead and print. All right, since I've already done that, I'm not going to worry about that at the moment. All right, so I've got those 3 plots. I would have printed them out on a paper. I've got them in a PDF file instead, and this way I can draw on my screen. If you happen to have a laptop that does the same thing, by all means, go ahead and do this. Okay, so here is my original titration curve. All right, that looks fine. I don't really have to do anything more with that right now. I'm going to go to this next page, which has my second derivative plot. Okay, and again, I'm using this to find a very precise equivalence point. And that precise equivalence point comes where this line crosses y equals 0. So right there. Now, if I look at my x-axis scale, that crossing occurs at about 25.02 milliliters. Okay, so I'm going to say my equivalence point is at 25.02 milliliters. Now, why am I interested in that? For the strong acid, strong base titration, I'm done there. But if I'm doing a weak acid, strong base titration, what I can also do is determine the Ka using this, because we know at 1/2 equivalence, the measured pH for a weak acid in this type of titration is going to be equal to the pKa value of the weak acid. Now, how am I going to do that? I'm going to go to my third graph, and I'm going to look at that region, okay? Half equivalence for this graph, or for this plot, is at 25, or excuse me, equivalence is at 25.02 milliliters, so half equivalence is going to be half that volume, which is 12.51 milliliters, to be very precise. Now, we're not going to get a very precise measurement from this, but we'll use it anyway. Okay, so if I look here, the 12.51 is going to come roughly here on my x-axis, which means it's roughly here on the titration curve. Now what I can do is I can go over and look at my y-axis. And it just so happens that it's right on this line on the y-axis where the pH is 4.625. Okay, now I'm going to round that. So I'm going to say for this titration, given the lack of precision, at 1/2 equivalence, the pH of my titration mixture is 4.63. All right, now that also happens to equal the pKa for this weak acid. Okay, that's what we know. Why is this so? Because at half the equivalence point, we have equal amounts of conjugate acid and conjugate base in our solution. We've got a buffer. If I have a buffer with equal amounts of conjugate acid and conjugate base, then the pH of the buffer is equal to the pKa of the weak acid. That's exactly what I have here. And so what I can say is if I want to determine the Ka for this weak acid, all I have to do is take 10 raised to the negative 4.63 power. In this particular case, that gives me 2.3 times 10 to the negative 5th. And so that's what I would report as my Ka. Now, if you do this on your titration curve lab, you're going to get good results, and you want to make sure that you explain how you did this. How did you get this Ka value? And the best way is to refer to graphs and just do exactly what I've done here. Hopefully this is helpful to you. Keep looking for more of these videos.